Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, welcome back. Let's take a look at the homework for yesterday's lesson. This particular M&Ms has to do with the triangle inequality and the side length patterns that we were working on Monday and Tuesday. First thing to look at when you are looking at three numbers is to decide, could those three numbers even make a triangle? And so you look at the two shorter sides and add them together. Are they greater than the longest side? If yes, that means that you'd be able to connect these points down here to the 11 centimeter segment and still have a little bit of space when these two connected at this point. So yes, these three could form a triangle. Now the question is, what type of a triangle? Is it acute? Is it obtuse? Or is it a right triangle? So we can go through and we learned that if you take the shortest side squared would be 9 square centimeters. And then the next longest one squared would be 100 centimeters. And the third one is 121. And if the sum of these two is equal to that, it would be a right triangle. If the sum of these two is less than 121, then it's an obtuse triangle, and that's what we have here. If it turned out that 9 plus 100 was greater than 121, then this would end up being an acute triangle, but it's not. This is definitely an obtuse triangle. Now, remember what we said earlier about how the two shorter sides have to add up to more than the longest side. And here's an example of that. The 5 meter line and the 7 meter line together are 12 meters. So if you were to lay them over across the 15 meter line, they would never be able to touch points here. So they could never form a triangle. So that's the first thing you have to look at is, do these side lengths even make sense to even make a triangle in the first place? If no, then just say they're not a triangle, and so you're not going to go through this exercise up here of squaring these different sides. So if you didn't get this clearly written in, I highly recommend that you get this in now. Think about the Pythagorean theorem, or you could just call them x squared, y squared, and z squared. It doesn't have to be the a, the b, and the c like it is down here. But the two shorter sides, when you square them and add them together, if that sum is greater than this number squared, it's always going to be an acute triangle. If you take the two shorter sides and square them and add them up, and it ends up being less than the longest side squared, then it's always going to create an obtuse triangle. And then what we're going to be focusing on primarily is the right triangles, which says that when you take a squared and b squared and add them together, they will equal c squared. And so this is a really important strategy, because if you know two of the sides, you can always figure out the third one by using Pythagorean theorem, by using this formula right here. There is a formula that you'll learn in trigonometry someday where you can deal with the obtuse and the acute triangles. We're nowhere near getting to that point, so we're going to stick with this. All right, what is this about? If you have 24 square tiles, how many different rectangles can you make? I only focused on the ones that were going in this direction. This 1 by 24 could have also been stacked upright and been a 24 by 1, but I didn't include that. So you got 1 by 24, you got 2 by 12, you got 3 by 8, and you've got 4 by 6. That says, can you make a square out of it, out of 24 tiles? And the answer is no, absolutely not. If you had 25, you could, because 25 is a perfect square. You'd have a 5 by 5 rectangle, basically. But with 24, that does not, there's no way to get the side lengths perfectly equal. I suppose there would be a way if you could take fractions of these unit squares, but no, we're not doing that. So we're just dealing with integers or whole numbers, and so no, cannot make a perfect square out of those. Lydia's drawn 4 straws of different lengths, and she's trying to form a right triangle. Well, what do we know about right triangles? We know that if you take the two shorter sides and square them and add them together, that will be equal to the longer or longest side of the 3 once it's been squared. So there aren't too many combinations that we can do here. We can do the 8, the 9, and the 15. We could do the the 8, the 15, and the 17, we could do the 9 and the 15 and the 17. And is there anything else? I don't even think there's any other combination. Is there of two shorters? Two shorters. I guess you could have, yeah, 8, 9, 15. Oh, you could have had 8, 9, 17 too. All right, so let's take a look at this. If we choose the 8, the 9, and the 15, then that's going to be what? That's going to be 64 plus 81. Does that equal 225? And I would say no, that's like 145. Then we take the 8, the 15, and the 17. So it would be 64 plus 225. And 17 squared, what is that, 329 or something like that? 17 squared, no, 289. 289 is, no, that's supposed to be equals 289. And sure enough, that's one that works. Now I'm just going to rule these guys out and make sure that they don't work. Is 81 plus 225 equal to 289? No, because I know 64 is, so that's going to be like 306. So no, that doesn't work. And then 8, 9, and 17 is 64 plus 81 is equal to 289. No, we said up here it was like 144. So yeah, this is the only one that works. The 8, the 15, and the 17 can be put together to form a right triangle, but none of the others can. All right, the Wild West Frontier Park now offers unlimited day pass. For $29, visitors can go on as many rides as they want. The original plan charged visitors $8.75 just to get in, and then they had to buy tickets, I guess, for the rides and pay $2.25 per ticket. So write an equation to determine the number of rides that would make the total cost equal for both plans. Okay, so this is equal values method. If y equals $29, that's what the original plan said, and now the new plan says you have to pay $2.25 per ride in addition to the $8.75 that we charge you just to get into the park. So if y is equal to this and y is equal to that, then this has to be equal to that. So we set it up as an equation. And then you'll have to subtract $8.75 from each side. And I'll use my calculator to do this. What is 29 minus $8.75? It is $20.25. So that means $20.25 is what they would spend on the rides alone. So if each ride costs $2.25, how many rides could you get in? Well, 10 of them would be $22, right? So I feel like 9 is probably the answer. So let's take the calculator and prove it. What is $20.25 divided by 2.25? It is in fact 9. So if you go on 9 rides, then it does not make any difference which plan they used. If you go on more than 9 rides, then you would wish that they had stuck with the original pricing of $29 for the day, unlimited rides. If you're the type of person like me that hates going on rides, but you're just hanging out with your kids because they love going on rides, then this is actually better because my number of rides would be 0. I would just be paying $8.75 to get in. And is this the last one? No, it's not the last one. Okay. Where are we in time? We're good. All right, so write a rule for the table at the right. To figure out what the rule is, we play that silent board game. What do you do to the 4 to make it an 11? You got to do the same thing to the -2 to make it a 1, and the same thing to the -1 to make it equal to -1. So if it's not really obvious what the pattern is, go ahead and try and figure out what the slope of the line is. Once you know what the slope of the line is by finding the change in y over the change in x, then you've got 3 parts of a formula and you can figure out what the y-intercept is without doing too much work. You could also plug these, all of these into a graph and then connect the dots and see where it physically goes over the y-axis, but we're not going to do that. So I think I'll take these 2 points right there. So the change in y to get from -1, I was supposed to highlight both of those. There we go. To get from -1 to -2 is that goes down 1. So my change of x is going to be -1. And to go from this point to that point for the y's, it goes up 2. So that is equal to -2, which means our slope is -2. Now remember, y equals mx plus b is the formula for all of these linear functions. So I'm going to plug this number in for m, put that as a -2, and then I'm going to choose any one of these. And I think I'm going to choose this one right there. My x is equal to -2. My y is equal to +1. And what I'm missing in this is I don't know what b is. So I'm going to just leave that as my variable. So what is -2 times -2? It's 4. And what number do you add to 4 to give you 1? Well, it must be a negative, right? So let's go ahead and finish the process by subtracting 4 from each side. And we get b is equal to -3. So that's your y-intercept. So the rule has to be y equals -2x minus 3. Now, that's great. We've got this rule. You should double check it to make sure that that's actually true. Let's plug in the number 4 here. What's -2 times 4? It'd be -8, and -8 minus 3 is equal to -11. That's what we've got there. So it works for that one. Let's try it for this one. -2 times -1 is +2, and 2 minus 3 is equal to -1, and that's what we get there. Okay, it worked for 2 of them. It'll work for all of them. There's no way we could have made mistakes and accidentally gotten the correct answer for that formula on both of those. If we got the right answer both times, we know this is right. All right, solve for x. Each part is a separate problem. They have to say that because, like in problems like number 6 here, where you solve for x was 22, you don't want to come to here and say, oh, I know it's 22, let's plug it in. No, these are all completely separate, unrelated problems. So do one at a time. So let's first look and see what is the relationship between this angle here, angle 1, and angle 5. It looks like they're corresponding angles of a transversal going through parallel lines, which means these two are equal to each other. So if they are equal to each other, then that means that 3x minus 18 has to be equal to 2x plus 12. I'm going to take away 1x from each side. I'm going to add 18 to each side, and that's how you get your answer for x is equal to 30. Now, if I plug in 30 here, that becomes 90 minus 18 is 72. And if I plug in 30 here, that's 2 times 30 is 60, plus 12 is also 72. So do the checks, make sure you didn't make any simple mistake. Moving on to the next problem. Angle 3 is here, and angle 6 is here. Those are alternate interior angles. When a transversal is intersecting parallel lines, they are equal to each other. So that means that 4x minus 27 is equal to x plus 39. So what is the value for x here? Take away 1x from each side, add 27 to each side. I'm going to have to show this. What is that, a 6? Is that 66? Which means x must be equal to 22, because 66 divided by 3 is 22. Check to make sure that that works. Is 88 minus 27 going to give you the same answer as 22 plus 39? 22 plus 39 is 61. 88 minus 27 is also 61. So yay, we got that right. And now the last one. What's the relationship between angle 4 and angle 6? They are on the same side interior of a transversal intersecting parallel lines. These two angles are parallel. No, they're not parallel. They are supplementary to each other. One's an obtuse angle, so this is more than 90 degrees. This is less than 90 degrees. This is acute, so they can't be equal to each other. Why are they supplemental to each other? Well, because, let me just back this up first. Angle 4 is supplementary to angle 2 because they're adjacent angles being formed by an intersection of two lines. And we also know that angle 2 is corresponding to angle 6. So those two are equal. So if 4 plus 2 is 180, then 4 plus 6 must also be 180 degrees. So angles 4 and 6 are supplementary to each other. So we're going to take this angle, 49 degrees, and add it to this angle, 5x plus 41, and their combined total has to be 180 degrees. So we combine like terms, 5x, 49 and 41 makes 90. When we subtract 90 from 180, we get 90. And 90 divided by 5 is 18. So if I plug in the 18 here, get 90 plus 41 plus 49, that should equal 180 degrees, and it certainly does. All right, I think that's it. No more. No, there is one more. Is there one more after that? No, goodness, there were a few problems on here. All right, problem 79. This is called, stop it. This is called an exterior angle, and it's equal to the sum of the two remote interior angles. So 46 plus 90 is 136. That has to be 136 degrees. And let me prove it to you. If that's 90 and that's 46, this one has to be 44 degrees because of triangle sum theorem. These two together add up to 90, plus 90 is 180. Angle X, this angle is supplementary to this one. So 180 minus 44 is going to give us 136. There we go. So the shortcut is just add the remote interior angles. Here, what's the relationship between angle 77 and X? This is an acute angle. This is an obtuse angle, so they are not equal to each other. Let's take a look and see. I know that this guy corresponds to this guy, and X is supplemental to this angle here, so X has to be supplemental to 77. So that means that 77 plus X has to equal 180 degrees. And when you subtract 77 from each side, that's how you're going to get your answer there. All right. Hope you did well. Hope you understood all this. That took a fair amount of time. There's a lot of information going on there. We are not going to do a new lesson today. I'm going to give you a check for understanding for the work that we've been doing with Pythagorean theorem. And then tomorrow there will be an assessment. But no homework. You won't have homework again until after spring break. All right. So enjoy your time off and make sure that you study and prepare for this assessment that you're going to have tomorrow, and today's check for understanding is going to help you with that process. All right, take care. See you later.
Hey, feeling good, like I should. When in dark, walk around the neighborhood.